Okay, let's look at a few more examples of other types of functions. So this next one, number 4, we have a rational function, meaning there's an x in the denominator. So I have y equals 3x plus 2 over x minus 2. Okay. So to find my x-intercept, I'm going to plug in 0 for y. Now anytime you're solving an equation that's got something in the denominator, I'm going to multiply through by the denominator so that these will cancel out. Now over here, 0 times anything is just going to end up being 0. Okay, so anytime you're solving a rational equation, get the fraction by itself first. So if there was like a random minus 3 out here, like I have over here, I would move the 3 over first and then multiply through by the denominator, and whatever you have here, distribute it in. But in this case, we're just getting 0. Here they're going to cancel the x minus 2 and then divided by x minus 2. And that's going to leave me with a 3x plus 2. Solve for x, so subtract 2, divide by 3, and that's going to give us our x-intercept. Okay. Now to get our y-intercept, I'm going to plug in 0 for the x's, so this 3x is going to 0 out, and the x is going to 0 out. So it's going to give us 2 over negative 2, making our y-intercept negative 1. So that'll be 0, negative 1. Now for an absolute value function, anytime you're solving an equation with an absolute value, okay, whatever's outside the absolute value, you want to move it over first. So I would have 3 equals the absolute value of x squared minus 1. Okay. Now remember, when you're taking the absolute value of something, that's how far it is away from 0. Okay. So whatever number is in here, okay, when you take the absolute value, since we're measuring a distance, is always going to be positive. So when you're solving an absolute value equation, you first need to make sure that it equals either 0 or a positive number. So say, for instance, this had been a plus 3, so we would have subtracted 3. Well, that would have given us the absolute value equal to a negative number. Okay? If that happens, you're not able to solve this equation. So you would put no solution here, meaning there's no intercepts, no x-intercepts. Okay? But in this case, since the absolute value equals a positive 3, I'm able to solve this equation. Because it is possible for the absolute value of something to equal 3. So what this means, when you're solving an absolute value, you're going to take whatever's inside, so x squared minus 1. So for the absolute value of this to equal 3, it either has to equal positive 3, or what's inside the absolute value has to equal negative 3. Okay. And then we're just going to solve each of these equations. So we're going to have x squared equals 4. I'm going to square root it, so that's going to give me positive and negative 2. So my first two intercepts are positive and negative 2. Okay. Here, this is going to give me x squared equals negative 2. So when I square root this, this is imaginary. Okay. When we're finding intercepts, okay, that's where it crosses the x and y axis, so we're looking for these points. Okay. We don't include any imaginary answers. Okay, so these are considered zeros. This would be plus and minus I root 2 for the zeros, but since we're specifically looking for intercepts, we don't include any imaginary. So I'm not getting any more answers from this one. Okay. Then to get my y-intercept, I'm going to plug in 0 for x. So that's going to give me y equals the absolute value, that'll be 0 minus 1, so the absolute value of negative 1 minus 3. Okay, so the absolute value of negative 1 is positive 1. So then we have 1 minus 3, so y is going to equal negative 2. So that will make my y-intercept 0, negative 2. Now, solving a square root function. Okay, you first want to isolate the square root. Okay, so when I'm finding my x-intercept, so plugging a 0 in here, I need to get rid of everything on the outside of the square root. So you want to add the 1 first. Think of it if you were solving like 2x minus 1. you would add 1, divide by 2. Same thing here. So move the 1 over, divide by 2, and then we can get rid of the square root. Okay, but just like with an absolute value equation, okay, before you get rid of the absolute value by splitting it up into 2 equations, you've got to make sure this is a positive number, because the absolute value of something will always equal a positive number, or 0 at the least. So same thing with a square root. Since the square root is in the problem, this is saying the positive square root. Okay, so when they give you the square root in the problem, it should always equal a positive number. If they wanted the negative square root, they would have written a negative in front of the square root. So this is saying the positive square root of 4 minus x equal to 1/2. Okay, so this has to be a positive number over here. So had this been a negative 1/2, we would have said there's no solutions to this. Okay, so make sure when you're solving an equation, before you get rid of the absolute value or the square root sign, you do make sure it's equal to a positive number. Okay. Then from here, I can square both sides to get rid of the square root. So that'll be 1/4 equals 4 minus x. Then we're going to solve for x. So what I'm going to do is move the x over to make it positive, and I'm going to subtract the 1/4. So I'm going to get a common denominator. So 4/4, that's 16 over 4. So 16 over 4 minus 1/4, that'll be 15/4. Okay, so my x-intercept for this one is 15/4, comma 0. Then to get my y-intercept, I'm going to plug in 0 for x. So that'll be y equals 2 times the square root of 4 minus 1. Okay, so again, this means the positive square root. So the positive square root of 4 is 2. So that's going to be y equals 2 times 2, which is 4, minus 1. So our y-intercept is going to be 3. So these are my 2 intercepts for this square root function. Now for this last example, okay, again, to find your x-intercept, you're plugging 0 in for y. So again, you need to move anything outside the square root over. And then to get rid of a square root, you square both sides. Okay? But before you get rid of this, this means the positive square root. So they're saying the positive square root of x squared plus 3 equals negative 27. Well, that is not possible. So there's no real solution to this equation. Okay? So that means there's no x-intercepts. Now to get the y-intercept, you're going to plug in 0. So that'll give you the square root of 3 plus 27. Now you can only add a root 3 with another root 3, so there's no way to simplify this. So we're just going to leave our y-intercept like this. So I'm going to have 0 and then 3 plus the square root of 7. So if you end up with a root plus a regular number, this is called a rational number, you just leave them separate. So let's just real quick go over when you're solving an equation when there's no intercepts. Okay. So the first time there's no intercept is when the expression is undefined. Okay, so we didn't go over one like this, but remember, an expression is undefined when you divide by 0. Okay, so if you're plugging in 0 for your x's and you end up with something divided by 0, that expression is undefined. That means there's no intercept. So if you're solving for the x-intercept and you get it to be undefined, no x-intercepts. The next case is when the square root is equal to a negative. So if I was solving for something, let's say we have the square root of x, let's say it's equal to a negative number. Well, that's not possible because this is saying the positive square root of x is equal to something. Well, that something would have to be a positive number. The same case with absolute value. So if you got the absolute value of x equal to a negative number, Again, that's not possible. When you take the absolute value, whatever's in here, whether this expression ends up being positive or negative, when you take the absolute value of it, it'll always equal a positive number, or 0 at the least. Okay. And then our last case, when there's no intercept, is if you get an imaginary number. Okay, so that can typically work out where you get like x squared equals a negative number, or when you're finding the y-intercept, you could end up with the square root of a negative number. Okay, so if you run into either one of these scenarios while solving for an intercept, it means there is not one of those intercepts, whether it's an x or y intercept that you're solving for.